Hi, I was asked by a student to do the number one, the first Hess's Law problem on the Hess's Law practice worksheet that I handed out. I had done the second one for you in the lecture, I think it was the thermochemistry part two lecture video, but just to see it again, to see the process again with another problem, I'm going to here do the first question. The first Hess's Law question. So what I wrote on the board is exactly what's written on the first Hess's Law question, and I will take it from here. All right, so in the question it says use the, what does it say? Use the thermochemical equations shown below to determine the enthalpy for this reaction. So at the end of the day, we are trying to solve the delta H for this reaction up top. That's the one that the question is about. That's the one that we don't know the delta H. So I don't know, sometimes I have, students think of this is our goal, to be able to solve this change in enthalpy. One of the ways that you can do that is using Hess's Law. Hess's Law questions will provide you a series of steps. Sometimes it's 2 steps, sometimes it's 3 steps, it can be 4 steps or more. On all of the ones that I'm giving you to practice, it's always 2 steps, so you can expect on the exam it'll probably be 2 steps, but maybe 3 steps for like an extra credit or something like that. But at the end of the day, you always do it the same way. All right, so if it helps you to, write that these are the steps, then maybe just write that these are the steps. Okay, so first of all, let me get a couple things out of the way. Usually in chemical equations, you're not supposed to use fractions as the coefficients. You can see here that they are using fractions several times. Thermochemical equations, where you've got the delta H written to the right, are kind of one place where that principle gets violated fairly often. So don't let it bother you. It's not anything that's wrong. It's just the way that sometimes thermochemical equations are written for various reasons. So don't make that a thing. It's not a concern. All right, so when you're looking at the steps, I always start with the first step. So this is the process that I follow. I will start with the first step. And let me say it like this. What we're trying to do is we're trying to get to the place where we can add up these steps. So we're trying to essentially add up the steps and get to the point that what we get when we add up the steps matches this goal. So what you're trying to do is get these 2 equations to kind of look like this goal at the top. And you'll see with practice how this comes together. So I always start with the first step, and I always ask 2 questions, okay? You're going to get different answers to these questions depending on the scenario, but these are always the same 2 questions. So the first question, do I need to reverse this step to get the species, like these are 3 different chemical species, on the correct sides as the goal? All right, so just take a look at a couple things. So calcium. Calcium here is a reactant. And between these 2 steps, this is the only place that I have calcium, between this step and this step. So I need to get it to be on the right side so that when I add these steps together, it's on the correct side. So is it on the correct side? And the answer is yes, it is on the correct side. It is a reactant in the goal, and it's a reactant here. Another thing I'll point out here, if you were to look at CaO, you can really look at any of them. But if you were to look at CaO, you would see it doesn't even appear in the goal. So don't make your judgment based on ones that don't even appear. What you're going to find out is that these end up disappearing when we add them together. But make your judgment always on the one for which this is your only chance to get it correct. So I've just decided I am not going to reverse this equation. No reverse. And I make myself a little note. I'm not reversing it. Now, the second question is, do I need to multiply the coefficients by some number to get them to be correct? So the coefficients being these things here, the coefficients. Now, whatever you multiply one of them by, you're going to have to multiply all of them by. You can't multiply the coefficients by different numbers. That doesn't work, because then it doesn't get balanced anymore. But let's come back to the calcium, because once again, this is my only chance to get calcium correct. Right here, calcium is a 1. Up here, it is also a 1. So based on that alone, I do not want to multiply this equation by anything. If I do it, we'll mess it up. So when you don't reverse and you don't multiply, you essentially don't change the equation. And so I usually just rewrite it. And sometimes it helps to rewrite it in a different color or a pen versus a pencil or whatever so you don't get confused. And if I didn't change the equation, I don't change its enthalpy. The number for the enthalpy stays the same. All right, so I've done everything I can with this step here. Now, the second step. And by the way, I will only give you steps that you need. I'm never going to give you steps that you don't need. It's not a trick question type of thing. You will always need both steps. Now, calcium carbonate. Let's look at this step here. First question, do I need to reverse it? Well, here in this step, it's a reactant. If I leave it on the reactant side, when I add up the equations, it's going to still be a reactant. But if you look at your goal, it needs to become a product. And this is the only time in both steps that you can deal with calcium carbonate. It's the only time he appears. So on that basis alone, I'm going to make a note. I need to reverse this step. Now, before I do anything else, ask the second question. Do I need to multiply the coefficients by some number to get them to match? And with this one, it's a 1. It needs to stay a 1, and on that basis alone, I'm not multiplying and no multiply the step by any coefficients. In the example that I did for number 2, you do have to multiply by coefficients. And just remember, if you multiply 1, you got to multiply everything by that coefficient, including the delta H. So for examples where you have that issue, look at the thermochemistry part 2 video, because I think that was one where we actually had to do that. But in this one here, we're going to reverse it, but not multiply it. So now just reverse the equation. So that reversing the equation just means taking the products and writing them as reactants. In either order, it doesn't matter. And the reactant will become the product. So that's what it means to reverse an equation. Now, as soon as you manipulate a step in any way, if you reverse it or if you multiply the coefficients by a number, you have to change the delta H. The delta H will change. And the rule is this: if you reverse an equation, you flip the sign of delta H. So instead of being 178.3 kilojoules, which is endothermic, it becomes negative 178.3 kilojoules, which is exothermic. All you do is flip the sign. Had we needed to multiply the coefficients by some number, we would multiply the delta H by that exact same number. And now we're almost done. Now we're at the point that we can add, this is a plus sign. Once you've kind of manipulated both steps to where they need to be, you add the 2 steps together. Adding steps together is literally just collecting everybody that's a reactant from both of them. This is why it helps to use the other colored marker, the red marker, because I'm adding the manipulated steps. So CAS plus 1/2 O2 gas plus CaO. I'm just listing everybody that was a reactant from both steps. Plus CO2 gas. Now I'm at the arrows. Now I list everybody that's a product. CaO solid plus CaCO3. All right. Now, oftentimes, very often, you will get species that can cancel. If you look here, you can see that the CaO, the calcium oxide, is present in the exact same amount. There's 1 here, and there's also 1 here. So just like algebra, you can subtract it from both sides of the equation, and it's gone. Okay? So you can almost think of this as it's not an equal sign, it's a chemical reaction, but you can think of it like an equal sign and subtract it from both sides, and it's gone. If you had seen it at this level, where you see 1 is a product, and you have the exact same coefficient, and it's a reactant, then you can do it at this level as well. That's totally fine. And now this is Hess's law. Hess's law states that if a reaction like this can be thought of just mentally as a sum of steps, which this one is a sum of this and this, if you think about it, it is, then his delta H, which is the whole goal of this question, will simply be the sum of their delta H's, this one and this one. And so if you just take that to your calculator, you will get the answer to the question. So negative 635.1 plus negative 178.3, and you'll get negative 813.4 kilojoules. And that is the answer. Practice makes perfect. I think if you can do all 4 of the ones from the Hess's Law worksheet, you will be fine for anything that you're expected on the exam. There's also homework problems from the textbook that will give you more practice. Each Hess's Law question will require you to do different things to the steps, just depending on what's needed to make it match the goal. But at the end of the day, you follow the same process every single time. All right, good luck. Hopefully that helped. Talk to you later.